Hi there. In this video, we want to talk about another factoring topic, and it's called factoring quadratic trinomials whose leading coefficient is 1. I know there's a lot of vocabulary here. We have talked a little bit about factoring, and we know the word trinomial. That means that there's three terms, okay? And so we got to get at the idea about what we mean by quadratic, okay? And so whenever you see this term, especially if you go to more math classes, you'll start seeing it more often. Quadratic is a polynomial whose degree is equal to 2. Now, we've mentioned the word degree, but we haven't used it a whole lot. So remember what the degree is. That's the highest exponent, okay? And so a quadratic polynomial uh, could be something like x squared plus 3x plus 2. Or I could have 5x squared minus 7x minus 3, something like that. Okay, so make sure you realize they're quadratic because our highest exponent is 2. All right, these are also trinomials because there's three terms. So that's what we're talking about with quadratic trinomials. Now we got to get at what we mean by this phrase too, that the leading coefficient is 1. Okay, and so this idea of the leading coefficient. Okay. In general, it's the coefficient on the degree term. Okay, like that. And so the degree term is the highest power. So it's another way to think about it is it's the coefficient that with the highest power. Okay, or the highest exponent to be a little bit more correct. Okay, and so if you look at these two right here, so let's look at those two examples right there. Well, we had x squared plus 3x plus 2 for one of them, or we have 5x squared minus 7x minus 3. So ask yourself what's the leading coefficient on each one of them. This one's a little easier to identify, and so the leading coefficient here, it's the coefficient on the degree term or the highest power. Here's your highest power, so there's the coefficient. And so the leading coefficient there is 5. Whereas on this first example, here's our degree term. There's not a coefficient written, and so remember, if there's not a coefficient written, that means that the leading coefficient is 1. Okay, and so what we're going to be talking about are in this video is just factoring trinomials that have this form right here, where the leading coefficient won't even be written, but there's an implied one. Factoring these kind of trinomials is quite a bit more complicated. So this will just help with some of the explanation, but if we think about a quadratic trinomial whose leading coefficient is 1, we can describe the general form of that thing based on what we just said. Like we just said, the degree term will just be x squared, or our variable squared in general. All right? And then what's going to happen is you're going to have an x term, and then you're going to have a term without an x on it. But we don't know what the coefficient on that x term is. So we could just call it b in general, and then we'll have a term that doesn't have an X on it, C, like that. Okay, and so there's some vocabulary to explain how the method to factoring these. And so this B is called the middle coefficient. Okay, like that. And then this C, since it doesn't have an X term, it's just a number. And so we call that the constant. All right. And so we have these two terms, and a rule for factoring these will make sense. Now, let me show you. I'm just going to, don't worry about how I get this, but in terms of what we're trying to do, if we look back at that example I wrote on the previous slide, okay, we'll see in a minute that this ends up factoring. It's not the kind of factoring you're thinking about where we're taking out a GCF. What we're going to do is we're going to write it as the product of two first degree terms. And in this example, this thing will factor as x plus 2 times x plus 1. Okay, again, don't worry about how I just got that. Okay, and so just remember what factoring is. It's taking something and writing it as a product of simpler things. And so since this is squared, the degree on each one of these parts right here is 1. So these are considered to be simpler. And then why is it a product? Remember, there's an implied multiply in between those. Okay, so that's the idea of what we're trying to get at, is we want to be able to start here and get to here. Okay. Now, if you're wondering if that's actually correct, what I wrote, remember what I said before, that with factoring you can always check. So at least we can check, and it might help you understand the rule once we get there. Okay. And so if I go and check that, remember what I would do. First, I would distribute the x, and then I would distribute the 2. In fact, some people call that foiling. I don't really like the word foil because it's just distribution. But anyway, if we go through that now, when I distribute the x, I'm going to get x times x, which is x squared. And then I'm going to get x times 1, that's plus 1x. Okay, now I'm going to distribute the 2, and so I get plus 2 times x, and then plus 2 times 1, which is just 2. And see, notice these two middle terms are like terms, and so they combine to give me that 3x plus 2. All right. So now, so the general form for a factorization, so the general form for a factorization, we'll start with that general form, except B and C will be actual numbers in a given problem. Okay. And then we're going to factor it as x plus some number, like right up here, we got that plus 2. And then we're going to factor it as x plus some other number. Okay. And the whole goal of this is to figure out what these two numbers are. Okay. And it ends up being a pretty straightforward rule, but we have to explain it a little bit too. One other thing to point out before I move on. So when a moment ago, I'm still using the same example, okay? But I wrote that x squared plus 3x plus 2 is equal to x plus 2 times x plus 1, like that. But remember, there's a multiply here, and it doesn't matter what order you multiply things in. So I could have got, this is another equivalent factorization. All right, I only point that out is that whenever you're looking at answers or if you're trying problems, and if you see that you have the same answer, but your factors are written out of order, you don't need to worry about that. That's actually correct. Okay. And the key thing is just to check, and then you'll know whether you're correct, whether or not you have it written in the order I do or in the opposite order. Okay. So let's talk about how to do this. All right, now we're going to come up with a rule in a minute ago, and I just kind of want to explain where the rule comes from. But if you want, you can skip ahead to the next slide and just get to the rule. But let's look at another one. It's a little bit more complicated, but it helps illustrate the rule. So this is one again. Don't worry how I get this, but I'm starting with x squared plus 5x plus 6, and in a minute we'll see how to get this. But it actually factors as x plus 3 times x plus 2. Okay. Let's check to make sure that I'm actually correct though. Okay, so to check, I start with my answer and I want to hopefully get back to what I started with. So I want to show that that product right here is equal to what I was given. All right, so remember how we check again. Hopefully this is repetitive, where if it's repetitive, it means you're getting it down. Okay, like that. So I do that double distribution there. And so whenever I distribute the x, I'm going to get x squared plus 2x. Okay, and then whenever I distribute the 3, I'm going to get plus 3x, and then plus 3 times 2, which is 6. Okay, like that. And keep in mind that that's 3 times 2. Now you can see I'm leaving a little bit of space because the line that I have written up above is really the key line. But those two middle terms are like terms, so I could combine them into 5x. So that does check. Okay. Now, if you look here carefully, though, for the method, notice that these two parts right here, without the variable, are the two numbers that showed up in the parentheses for my answer. Okay, like that. And then what's also true about 3 and 2, they multiply to give 6. Okay, and so again, remember the whole idea with factoring, whenever the leading coefficient is 1, all right, actually ends up being a simple rule, is that I'm just going to have x plus some number and x plus another number for my answer. And what I'm trying to illustrate is how you can get these two numbers. These two numbers should multiply to your constant, and then look what else they do. 2 plus 3 plus 2 is 5. So they add up to the middle. Okay. And so that kind of illustrates the rule for how we factor a trinomial whose leading coefficient is 1. Okay, so we're ready to lay out a method for factoring. Remember, this is a quadratic trinomial whose leading coefficient is 1. The idea is to write it as x plus some number times x plus another number. Okay, and like we just saw, what we need these two numbers right here to do, they need to multiply to the constant term and they need to add to the middle term. Okay, and so that's the key phrase there, is that you find two numbers. Now, I will tell you this isn't always possible, so I'll add in that caveat right there. If possible, that multiply to c, but I'm going to use words here. Multiply to the constant. If you're writing this, leave a little bit of space because I'm going to put in a parenthetical phrase there. But also that add to the middle coefficient. Okay, like that. All right. Now, the thing I need to add in here, two numbers that multiply to the constant, those are factors of the constant. Okay, that's what factors are, things that multiply. Okay, so the way I usually phrase this is that you need two factors of the constant that add to the middle. Okay, and so it's that that ends up being pretty much that straightforward like that. And now you are not just finding the numbers, then that just tells us what the factorizations are. Then that first number that we're trying to add into the factorization is the first of these two numbers up above right here. Okay, and then that second question mark up above is the second of the two numbers. Okay, like that. So just if you're having trouble seeing, let's go back to that x squared plus 5x plus 6. Okay, so two factors of 6 that add to the middle are 2 and 3. Okay, so that's these two numbers that I'm referring to up here and there. Okay, but once you have those two numbers, then you write the factorization. You say x plus the first times x plus the second. And then again, notice that I was talking and not thinking. If you look back at that previous slide, I had these written in the opposite order. I had x plus 3 times x plus 2. But those are the same thing because it doesn't matter what order we multiply in. So that's how we get that answer. And a couple things before we move on to that. Sometimes these will end up becoming subtractions. We'll see, like that, and it depends on whether these are all pluses or if there's some minuses in here. And then the other thing to point out is this isn't always so easy to do, finding factors of a number that add to another number. So it's not quite. So this sounds easy right now because this was a pretty basic set of numbers. So we want to talk about a method for actually going through a list and determining if it's possible, okay? Because there's going to be some that aren't possible. And one quick note before we move on to, it's a note on that if possible. What's going to happen? So remember what we need. We need two factors of the constant that add to the middle. Very often that's not possible to do though, okay? And so if that ends up being not possible to do, be very careful. And that's the reason I'm going to show you a systematic way to make sure that you can exhaust all the possibilities. But if you're convinced that that's not possible to do, then how do we answer the problem? All right, well, think back to numbers. What do we say about numbers that don't factor? We call those numbers prime numbers. And so I don't know why I wrote that over there, but so whenever it's not possible to get those two numbers, we say that that polynomial is prime. Okay, so let's start doing some examples now. Okay, so here we go. Here's two examples. We're going to factor them if possible. Okay, and the key thing is just to try to understand what you're doing. First of all, in turn, we can kind of set up the answer. Since our leading coefficient is 1, we know that the factorization is going to be x plus some number times x plus some other number. Okay, like that. But what do we need those numbers to be? So what do we need? We need factors of the constant. So what's our constant term there? We need factors of 16 and that add to the middle coefficient. So that add to 10. Now this is going to be one thing. Some of you are going to be really quick and can see the numbers right away. Some of you aren't going to see it so quickly. And it just revolves around number sense. And even if you already see them and you feel like you're quick, there are going to be problems that kind of stump you. So you want a systematic way to go through all the possibilities until you finally find one or convince yourself it's not possible that that thing is prime. Okay, so what I do is I make a little chart here. Okay, we're talking about factors of 16. Okay, and we're really talking about factor pairs. Okay, like that. And then we're going to look at what they add to. So that's a sum. All right. And so, but there's a way just to make a list of all the possibilities. And the way you can do that is just start with 1 in the number. So the first factor pair of 16 is 1 and 16. Okay, like that. And then add those two numbers together. They give us 17. Does that work? We need them to add to 10. And we got 17. So these two numbers don't work. And so, all right. And what you do is you just go to the next highest. You start with 1 and the number. Okay. Then you go to the next highest number that divides into 16. So 2 divides into 16. Okay. What do you multiply 2 by to get 16? You multiply it by 8. So 2 and 8 is a factor pair. What do those two things add up to? They add up to 10. And isn't that what we're looking for? We're looking for them to add to 10. And so this is what we were looking for. Ta-da. Okay. Now, if you do it this way, just remember that the just remember that that's not the answer. That just gives you the answer. Okay. And so what is the answer? It's going to be x plus 2 times x plus 8. Okay. Like that. And please try to get in the habit of checking. It's really easy to make mistakes with this. So we think our answer is x plus 2 times x plus 8. Okay. But how do we check that? We distribute to see if we can get back to the answer from that. All right. And so whenever we do that, we get x times x, which is x squared. We get x times 8, which is 8x. We get 2 times x, which is 2x. And we get 2 times 8, which is 16. So that's x squared plus 10x plus 16. And that does check. So now we can be convinced that that's the answer. By the way, too, again, always remember this too. Some of you may have got it the answer this way if you paused and tried it. Okay, that's perfectly fine too. It checks as well. All right. So now in this next one, what do we need? We need factors of the constant. So we need factors of 20 that add to the middle. So that add to 9. Okay, like that. And so again, we'll end up having something that looks like this. All right, like that. And so we just go and we make our factors of 20 and then look at their sum. Okay, now one thing that people get confused about too, just to be aware of, is here you're looking at factors and then you're adding them, okay, or you're looking at sums. All right, so keep in mind factors are things that multiply. So I'll have people start making this list and they'll write 1 and 19. Okay, those are numbers that add to 20. We're not looking for things that add to 20. Whenever we're talking about factors, we're talking about things that multiply to 20. Okay, and to help you too, the first set to look at is 1 and the number. And very often actually ends up working. It doesn't in this case. All right, because if I add those two together, I get 21. So that doesn't work. All right, and then you just go up to the next number that divides into whatever you're looking at. So 2 goes into 20. 2 times 10 is equal to 20. Those add up to 12, but remember, what are we looking for? We're looking for them to add up to 9, so that one doesn't work. All right, 3 is the next number, but it doesn't go into 20 evenly. All right, so what's the next number that goes into 20 evenly? 4. And it's 4 times 5, which equals 20. You add those together, you get 9. So that's what we're looking for. And so remember what that means. It looks like our answer is x plus 4 times x plus 5. Okay, but what else should we do before we circle that? We should make sure that we're correct. And so let's go and check that. And this happens all the time in advanced math classes that I do. People will write down a factorization and not check it, and then they do a bunch of extra work based on it, and it's all lost because they didn't check their factorization, and it ended up being incorrect. Okay, so to check this, I do x times x, which is x squared, and then plus 5 times x, which is 5x, then plus 4 times x, which is 4x, and then plus 4 times 5, which is 20. And if you add those two middle terms together, we do get our answer, so that checks. And so now we can circle our answer and give yourself a big pat on the back. Okay, so let's look at two more now. So we're looking at x squared plus 7x plus 4. And so what do we need? We need factors of the constant, so we need factors of 4 that add to the middle. Okay, so that add to 7, like that. All right, and so we can start making our chart here. And so we get factors of 4, or factors of 4, and then we're going to look at their sum. All right, well, factors of 4 are numbers that multiply to 4, and you can always start at 1 in the number, so 1 and 4. Those add up to 5. 2 goes into 4, so 2 and 2, those add up to 4. Okay, those don't work. And now, if you think about it, 3 doesn't go into 4, 4 goes into 4, but we've already looked at that case right there. Okay, so this is a big advantage to making this chart is these are all the possibilities. There's no other possibilities. And so none of these work. And so in this case, how would we answer that? X squared plus 7x plus 4 is a prime polynomial, like that. And so that would be the answer to that problem. Okay, now things start, as soon as you start thinking things are pretty easy, they get a little bit tricky whenever we start putting subtractions in. So here we need factors of negative 15. Okay, do you see that? I meant to pause and ask you. All right, so we're not just looking at the number, that sign's important. If you're wondering why I'm saying negative 15, remember I can think about that as being plus negative 15. So our constant's actually negative 15. Okay, so we need factors of negative 15 that add to positive 2. You could, to remind yourself, you could say plus 2 or you could just write 2. Okay, now that affects things about how we set up our table to try to find them. Okay, because we're looking at factors of negative 15. So ask yourself, how do you multiply something and get negative? All right, and so to get that to happen, one has to be positive and one has to be negative. All right, so you can always start at 1 in the number, so 1 and negative 15. Okay, that's negative 14 if you add those together. Okay, so this doesn't work. Now I want to point out something else though that's important here, that another factor pair of negative 15 is negative 1 and positive 15. But notice whenever I add those together, I get 14. So you can look at the pairs of factor pairs, but notice that they only differ by sign. So the only time you really need to look at both sets of these is whenever this number comes out and its sign is off by what you're looking for. So if this had come out to be negative 2, then I would want to look at this second pair. But if the number part isn't even close to what you're looking for, you don't need to look at both pairs. You can just look at the one. All right, I hope that makes sense what I was just saying. All right, now this one's also interesting in where you go from here. So we looked at 1 and negative 15. The next number up is 2, but 2 doesn't go into 15. So we got to find another number. What's the next number that goes into 15? 3. Now remember, we need this to be negative, so I'd want to do 3 and negative 5. Okay. Now you add those together. What's 3 plus negative 5? It's negative 2. And see, this is what I was talking about a minute ago. So since we're looking for positive 2, but we got negative 2, what that means is I just need to reverse the signs around right here. So I'd get negative 3 and positive 5 like that. Now make sure to check. Don't assume that it's going to come out right. But now negative 3 plus 5 is positive 2. So that does work. All right. And so there it is. Now in terms of the factorization, remember that we usually say x plus and x plus, right? And then our first number is negative 3 and our second number is 5. So notice that I have this plus a minus right here, and we don't ever write that in answers. And so how would I really want to write my answer? I'd want to rewrite that with a subtraction like that. So there is what looks like the answer. I would go and check it still. And so if we do our check, we have x minus 3 times x plus 5 like that. And I go and distribute the x's. Again, I hope this is repetitive because that's the point. Now be careful on that second part. You're distributing negative 3. So whenever I distribute the x, I get x squared and then plus 5x. And then I have negative 3 times x. That's minus 3x. And then I have negative 3 times 5. That's minus 15. Okay. And then I go and collect my middle terms here. 5x minus 3x is plus 2x minus 15. And then look, here's what this is what I should get. Make sure that it's the same as what you started with. Double check those signs too, because it's real easy to mix those two signs around and think you got it right. Okay. And so that is the answer to that problem, though. All right, so let's look at a similar one. Now, the key thing is the bigger the constant gets, the longer the process might be. So just be prepared on this one. It might take us a minute or two, depending on your number sense too. I have seen several students that can just look at this problem and say, "Oh, it's those two numbers right there." So if it takes you a while, don't worry about it. Just be systematic about it. Okay. But if you see it, go ahead and write what you think the answer is, but make sure to check it. Okay. So what do we need here? We need factors of negative 48, the constant, that add to the middle. Okay, so that add to negative 8, like that. All right, so like I say, even if you're quick, take this as advice. Know how to make this table because there's going to be ones that throw you. Okay, and then we're going to look for the sum, and we're hoping that that sum equals negative 8. Just remember that you can always start at 1 in the number. That's very helpful. Okay, 1 plus negative 48 is negative 47. Okay, and we needed to add to the negative 8 here, so those aren't equal to each other, so that doesn't work. Now, again, since this number is way off of that, I don't need to reverse those signs around there. Okay, so what's the next number that goes into 48? 2. If you don't know how to get this second number right here, what do? You take 48 and you divide it by 2, or negative 48 and divide it by 2. Okay, and so we get negative 24. You add those two things together, you're going to get negative 22. That doesn't work out either. Okay, you go to 3, and if you're not sure if a number goes into the number that you're looking for, type it in on your calculator or do it longhand. So type in 48 divided by 3. If it comes out even, then it does. And 3 does divide into 48. Now remember, we're really dividing into negative 48. So we get negative 16. Okay. If we go and add those two numbers together, we get negative 13. Okay. And remember, we're looking for negative 8, so that doesn't work. What's the next number that goes into 48 or negative 48? 4 does. Okay, if you don't know how many times, you just divide it on your calculator. You'll get negative 12. What is 4 plus negative 12? Oh, yeah, that was good news right there. It's negative 8. That's what we were looking for. So it looks like the answer is what? X plus 4. Now it's going to be x plus negative 12, so hopefully you'll get into the start noticing it. Oh, what did I do wrong there, though? Do you see it? I changed my variable name. Okay, so my variable's y. So I have y plus 4, like that. And then, like I say, you could write y plus negative 12, but then on the next line, you'd want to change that to a minus. So this is y minus 12. That, that's the answer. Well, why did I stop myself there? I think that's the answer, but I don't know that's the answer. And at the very least, you can look at this as a lot of practice with multiplying too. A lot of people get to the point with checking that they can actually do it in their head, but you won't get to that point until you just practice it a lot. So this is kind just look at it as free practice. I'm not charging you extra for it. Anyway, we get y times y, which is y squared. We get y times negative 12, which is minus 12y. We get 4 times y, which is plus 4y. And then we get 4 times negative 12. That's negative 48. Okay. And so now I add my two middle terms. I have negative 12 plus 4. That's minus 8. Okay. Look at this. Look at what you started with and make sure they're the same. And they are. So that does check. Now I can officially circle that and give myself a pat on the back. All right, now let's look at this problem. It looks pretty tame, but there's a tricky part to it that a lot of people have trouble wrapping their heads around. Okay, so let's just follow our normal rule. We need factors of the constant. So what's my constant? It's 7 that add to the middle. Okay, what's my middle? It's not just 8. Remember, we got to keep up with signs, so it's negative 8, and that ends up being the source of the trouble here. Okay, so this seems pretty basic because 7 is a prime number. Okay, and so the factors of 7, and then we'll look at their sum, right? But since 7 is prime, it seems like the only factors are 1 and 7. Okay, that's going to add to positive 8. And that's kind of a clue here to what we need to do here. So here, if I look at these two factors, they're always going to add to a positive number, but we need to get a negative number. So is this ever even going to be possible? And I will just tell you it is. We got to think about that. And so the key thing is anytime you're looking for factors of a positive number that add up to a negative number, you need both factors to be negative, okay? Like that. All right. Also, if you think about what I said a moment ago, um, if this if the sum is only off by the sign, then you need to change the signs of your factors. So that may have been another clue right there. So what we really should have looked at is negative 1 and negative 7. And then whenever you add those together, you get negative 1 plus negative 7. That's negative 8, and that actually works. Okay, so if you think along these lines right here is x plus a number and x plus another number, like that, our two numbers are going to be negative 1 and negative 7. Okay, but then again, remember that we'll want to combine these into a subtraction. So, and you can cut that process. You don't have to put this line in there. Just anytime you have a factor that's negative, it will actually change that into a minus. So it looks like our factorization is x minus 1 times x minus 7, like that. But we want to check it, so we can come over here and check. Hope that's not too sloppy for you, but we have x minus 1 times x minus 7. So first I distribute the x. I get x times x, which is x squared. I get x times negative 7, which is minus 7x. I get, then I distribute the negative 1, so I have negative 1 times x, that's minus 1x, like that. And then negative 1 times negative 7 is positive 7, like that. And then I add those two middle terms. Negative 7 minus 1 is negative 8, so minus 8x plus 7. That checks. Okay, and so now I know I'm correct. All right. All right, let's look at one that's a little bit more complicated. So t squared minus 10t plus 24. All right, and so we need factors of positive 24 that add to negative 10, right? The middle. So we need factors of the constant that add to the middle. Okay, like that. And so we can make our chart here. Um, so we have factors of 24, and then we look at their sum. All right, and we need that sum to be negative. Okay, like that. So we need factors of a positive number that add to a negative. So that's telling you right there that you need both the factors need to be negative. Okay, like that. And so we just start with one in the number. Well, except we need both of these factors to be negative. So we'd start at -1 and -24, like that. And if we add those together, we get -25. All right, like that. And then we go to 2. 2 goes into 24, but we need it to be negative. So we get -2 and -12. Add those together, you get -14. So none of these are working so far. 3 goes into 24, but we need it to be negative, so we have -3 and -8. And so what do we get? We get -11. All right, if we add those together. So not working, it's not looking good. What's the next factor pair? 4 goes into 24. We get -4 and -6. What happens whenever we add those two together, though? We get -10, which that does work. Okay, so we do have our numbers here. And so let's see if I can remember what my variable is this time. So we got t plus -4, which we could just abbreviate and write t minus 4, save ourselves a line, times t minus 6, like that. Okay, and then again, please try to get in the habit of checking. Okay, that's a minus there. And so again, I do my double distribution. I distribute the t. So I get t times t, which is t squared. T times -6 is minus 6t. Then I distribute the -4. I get minus 4t. And then I have -4 times -6. That's positive 24. Like that. And so I get t squared. -6 minus 4 is minus 10t plus 24. Make sure that is what we started with, and it is. And so now we know we got the answer. One thing too, and I'm going to illustrate this in the next example, but some people teach this method, this factoring method, with more of a guessing and checking idea. You basically just write this general form right here. There ends up being some rules based on the constant and the leading that tells you whether or not you get pluses or minuses in here. If you look back at those examples, the problem is A, it's easy to get, especially whenever your constant is big and has a lot of factors, it's easy to get confused about if you've covered all the factors like that. So you might be saying something's prime whenever it's actually not. And then uh, and that's the main thing. And then also it just requires a lot of number sense and being able to in your head come up with factor pairs of numbers. So I highly uh, encourage this method. And I'm not saying you need this on every problem. There's some problems that you can just see those two numbers. Go with it and just write what you think the answer is. Just make sure to check it that you got it correct. But there's going to be some problems where you just can't see and convince yourself. So you need some kind of method there. So yeah, let's make sure to look at one tricky one here and see whether or not this thing factors. And so we need factors of the constant, so 128 that add to the middle. Okay, so this is what I was talking about a minute ago. 128 it actually has a lot of factor pairs. Okay, and so if you just try to do this by guessing and checking through it like this, it's easy to skip over factor pairs accidentally, and then you might say something's prime whenever it's not. Okay, and so this is a big advantage to this more systematic way of doing it. Okay, and so notice that both numbers here are positive. So we're looking at factors of 128, and then we want to look at their sum. Okay, like that. And I will be honest with you, I think this one's prime, but I'm not sure. I just made up the 48 there. I just wanted to show you about having to go through a larger constant number and all of its factors. Okay, so this is the thing. You just can always start at 1 and 128. Add those together, you get 129, but we want it to be 48, so that doesn't work. The next number that goes into 128 is 2. Okay. 2 goes into 128, what, 64 times. Like that. Add those two numbers together, we get 66. Okay. Does 3 go into 128? If you don't know, you just type it in on your calculator. You'll get a decimal, so it doesn't. Okay. Does 4 go into 128? If you don't know, just type it in on your calculator. I happen to know that it does, but just type it in. you'll see you get a whole number there. You're going to get 32. Those two add up to 36. Okay. Now, this is nice to know too. Okay. So notice that that doesn't equal 48. All right. This is nice to know. It seems like we should keep going on. The next number that goes into 128 is 8. Okay. So you could just keep going until you finally exhausted the list. But I claim from this line right here, we can already tell. And why would you say that? If you look at those last two sums, here we got 66 and here we got 36, and in between those is 48, the number that we're looking for. So whenever you're writing out your sums, if you pass over what you're looking for, you don't need to go any further. We know right now what the answer is. The answer here is prime. Now, prime's a little tricky because there's not a way to check that. So whenever you say something's prime, you might want to go back and make sure you covered all the possibilities, at least up to the place where it passed over what you're looking for. Okay, well, I hope that helps. And factoring, especially if you're going further in math, it's something that we just do all the time to solve more advanced problems. So hopefully that makes sense. Let me know if you have any questions, and all the best.